My name's Bo Ellis. I'm gonna do some statistical problems for y'all today. So starting off here, we got problem one. We got a data set of house prices, and our first question asks us to find the mean and the median. So we'll look here, we'll find median first. So median is your middle number. So I'm gonna look at this data set, and you can look at it just eyeballing it, but I'm gonna count them out just so we can do it the easiest way. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers. So if I'm in the middle of that, that'd be 4. But since it's an even number of data amount, we have to divide the two middle numbers by 2, or add them then divide by 2. So I'm looking here in the middle. I'm gonna take 145,000, and I'm gonna take 150,000, and I'm gonna add both of those. So I'm gonna do 145,000 plus 150,000, and that's gonna get me 295,000. When I get that number, I wanna divide that by 2, as shown there. And I'm gonna get 147,500. So I'm gonna write that as our median is 147,500. So that's our median. And our mean is a little bit tougher to find, but it's not too bad. So we're gonna take, so for the mean, you wanna get all your numbers in your data set and divide that by how many numbers you have. So we've got, as we counted before, we have 8. So I would take 120,000, and I would add 135,000, then I'd add 140,000, 145,000, sorry, it'll take me a second, 150,000, I'm gonna take 152,000, plus 154,000, and then lastly, 800,000. That's gonna get me 1,796,000. Okay. I'm going to take that, as I said for mean, I'm going to divide that by how many numbers we have. So again, 1, 2, 3, 4, 5, 6, 7, 8. So divide that by 8. And then when you do that, on your calculator, you get 200. We'll put it down here so I have more space. 224,500. So that is our mean. That's going to be $224,500. Everything's in dollars. Everything is in dollars. All right. So that's 1, and then now on to 2. Which measure represents typical house? So this answer to this would be median, and it's median because when you have mean, when you have bigger outliers like a huge number, it's going to affect it more often. So that's why this 224,000 is so much higher than this, is because that mean's taken into account, they say 100,000. And a mean, typically with those larger numbers, is going to get skewed, so you can get right skewed, left skewed. In this case, a little bit right skewed. But median takes the better average of these numbers that are all closer together and finds that middle number. So it'd be median for this data set. It could be different, but for this one's median. And then the last one, number 3, explain how the outlier affects the answer. Well, we kind of already said that. 800,000 is going to skew that mean and make it a lot higher. So in this case, it's a higher outlier. It could be a lower outlier, but in this case, it's 800,000. So it affected the mean, inflated it more. So that's the first problem. All right, so our second problem now. Question 1, we have find the 5-number summary. So that is we'll start with minimum. It's your minimum, your Q1, your median, your Q3, and your maximum. So we'll find our minimum first, pretty easy. That's gonna be 55, and that's our lowest number. So minimum is equal to 55. Okay, and then our Q1, so we're gonna break it into halves. So we have 1, 2, 3, 4, we have 1, 2, 3, 4, 5. So that's this left side. 70 is gonna be our median because that's our middle number, like we did question 1. And then 1, 2, 3, 4, 5. So we have to broke up here and here. So Q1 and Q3, we find those looking at the middle number of these two data sets. So this middle number here would be 62. So that's the middle of these 5 numbers. So it's easy. When it's 5 numbers, you can just look at the middle number. That's what it'll be every time. So this one, in this case, would be 62. So Q1 is 62. And then our median, as we already said, is 70, because that's the very middle number. So it'd be 70. And then Q3, which is going to be the middle number of these 5 like we did over here. So that'd be 80, because that's right in the middle. So Q3 And then our maximum, it's just our biggest number, so it would be 95. So that is our 5-number summary. That's it for number 1. And then number 2 tells us to compute the IQR. So to compute that, you would just take Q3 minus Q1, so it would just be 80 minus 16, oh wait, no, sorry. 80 minus 62, which gives us, I'll just do it out for this. No, 80 minus 62 equals 18. So that is our interquartile range, our IQR. So now we have to identify any outliers. So we'll start with Q1 for our lower bound. So the formula for that, we would do Q1, which is 62. We do that minus 1.5 times our IQR, which is, I'll put a 0 there, is 18. So I'll put that in my calculator. I'm going to do 62 minus 1.5 times 18. That gives me 35. So that is our lower bound equals lower bound. Then our upper bound is going to be a little bit different. It's going to be our Q3, so which is 80. It's going to be plus this time 1.5 times 18. So for that one, we do 80 plus 1.5 times 18. That gets us 107. So pretty much what that means is, this is our upper bound. If anything's below 35, it's an outlier. If anything's above 107, it's an outlier. So as you can see, we have no outliers, so part 2 to that, no outliers. Now for our last question, we have to draw a box plot, identify any outliers. So we kind of did that. All right, not identify, this should be the shape of the curve. So the box plot, we're going to start with, we need 5-number summary. That's the numbers you need in your box plot. So we have our minimum, which is going to be 55. And then our Q1, we said is 60, or I'll go ahead and our maximum too, 95. So our Q1, doesn't have to be perfect here, but just roughly the same idea. So Q1 is, we said 62. So I guess right about here. So that's where our box starts. And then our median, we said was 70, so right about here, kind of in the middle. And then our Q3 is our last line of our box plot, so that would be, we said 80, so it's kind of over here. So then we're going to draw our box, median, Q3, and just draw that out, connect there, connect there. So looking at the shape of this, to see if it's skewed or not, it's honestly overall pretty symmetric. If you had to say anything, it may be a little bit right skewed because that distance from 55 to 62 is a little bit less than the 80 to 95. But overall, pretty much symmetrical, and that's problem 2. Next question, problem 3, tells us that package weights shipped by a company are approximately normal with a mean of 12 pounds and a standard deviation of 2 pounds. So question 1 says, what proportion weighs between 10 and 14 pounds? So if we're looking at 10 and 14 compared to this mean, it would be 1 standard deviation outside of it because 12 minus 2 is 10, 14 plus 2 is, or 12 plus 2 is 14. So we know the answer to this is going to be 68% because of the 68, 95, 99.7 rule. So if we draw out a normal curve, we know that everything within this section of the portion is 68%. We know everything 2 standard deviations outside is 95%. So this is 95%. And then we know that everything 3 standard deviations outside the mean is going to be 99.7. That's just the 68, 95, 99.7 rule. So that tells us that the proportion that's in between 10 and 14, which is just 1 standard deviation, right here, is going to be 68%. So 68% is your answer. So number 2, what proportion weighs more than 16 pounds? So 16, so we know that our mean, first off, right down here is 12. So the last one was only 1 standard deviation outside, 10 and 14. So you knew that was 68%. This time we have 16. So we're going in terms of 2, because our standard deviation is 2. So if we do 2, that's 14. 2 more would be 16. So that'd be 16 right here. So it's asking what proportion weighs more than 16. So we're trying to find this little area right here of data set. So we know that, okay, let's think about this logically. If this line to here, if we know that's 95%, we know that we have 5% left in these two fractions of 3 standard deviations outside. So we look at these two, that's 5% remaining for that total count of the weight packages. So we have to divide that by 2, because we're not looking for anything over here, that's the other half of 5%. We're looking at this, what's more than 16. So we take 5, that 5%, we divide that by 2, that gives us 2.5%. So that is your answer. 2.5% of the packages weigh more than 16 pounds. Lastly, use and briefly justify the 68, 95, 99.7 rule. I've kind of been doing that. So again, that rule just says that if anything's 1 standard deviation outside, that's 68%. That's what question 1 was. If anything is more than 2 standard deviations outside, it's going to be 99.7. In this case, it was 2.5 because we didn't want to get the full 99.7. We just wanted to divide that by 2. But yeah, that's the rule and that's the question. All right, so our last problem, question 4. We start off with, assume SAT math scores are normal with a mean of 500 and a standard deviation of 100. So we want to find for number 1, find the score that marks the top 10% of students. So we know if you're in the top 10% out of 100, you're in the 90th percentile. So first off, we've got to find the z-score for that. So I'm looking at my z-table. I'm looking at the number closest to 0.90 or 90%. That's going to be 1.28 because on the z-table it's 0.8997. So we'd use 1.28. So I'm going to have 1.28 right here. But our formula for this, you take your z-score, okay? You're going to multiply it by your standard deviation, which is 100. And you're going to add your mean to the left of this. So it'd be 500. I should have probably wrote the 500 first, that's okay. So you're going to have it like this, then equals. So I'll compute that real quick. So that means the cutoff for the top 10% is going to be 628. That is the score you need that marks the top 10% of students. So you can pass that, be in the top of 10%. So that's number 1. Number 2, kind of the same thing, a little bit different numbers though. So we're going to find the score that marks the bottom 25% of students. So I'm going to go to my z-table, and I'm going to look at the number that gets me the closest to 25%, 0.25. That's going to be negative 0.67. I'm going to put negative 0.67, okay? So same thing, put it in parentheses. I'm going to put my standard deviation. I'm going to put my mean, so 500 plus negative 6.7 times 100. So I'm going to put that in here. And whenever I compute that, I'm going to get 433. So that means that my bottom marker is 433. That marks the 25% of students that are at that spot. So that is the problem for me.